Welcome back to part 2. We're going to go ahead and finish problem 20 here. And when we left the last video, we had combined like terms in the numerator, and really we can see now that we can factor again. This time, remember up here we factored out the tangent that we saw? Well, look here, we can factor out a 2 and a sine. If we factor out 2 and one of the sines, the first term is just left with a 1 plus, but if we factor out the 2 and the sine out of the sine squared, I'm just left with another sine. Do you see what's happening? These factors right here are the same, and they can cancel. They can reduce. It essentially is 1. So now you're multiplying 2 sine over cosine, but you know that sine over cosine equals tangent. And so you have reduced that, both those fractions, that difference, into one term of 2 tangent u. All right, last one we're going to do together is number 21 here. Number 21 says that you've got 2 plus tangent squared over secant squared minus 1. Now this problem has some squares in it, and so you should have some little bells going off. Ding, ding, ding. You know what you're going to use, one of your Pythagoreans. Now, the Pythagorean here has tangent squared plus 1 is equal to secant squared. All right, but I've got 2 plus tangent squared over secant squared. So if I wanted to, I could break that down, right? I could break down that 2. Let me show you. So we could say this was 1 plus tangent squared, these are x's, over the secant squared. We still have that minus 1, but 1 plus tangent squared is equal to secant squared. So we have 1 plus secant squared over secant squared. We still have that negative 1 there. So if I write this as 2 separate fractions, I would have 1 over secant squared plus secant squared over secant squared minus 1. Well, that goes to 1. So I essentially have 1 over secant squared all by itself, plus 1 minus 1, but I can't leave it as a fraction, and 1 over secant squared would just be cosine squared. Ta-da! Now, that is perfectly valid and a perfectly good way to do that problem. I'm going to show you another way, because there's definitely many ways to work a lot of these problems. And that I know frustrates some of you, but there's not just one way to work it. So I am going to show you another way to work this problem, and that is, let's get a common denominator. This has a denominator of secant squared. Let's change that 1 to secant squared over secant squared. All right, so I'm going to have 2 plus the tangent squared over the given secant squared, and I'm going to subtract secant squared over secant squared. Well, when I combine those, all right, I'm going to have 2 plus tangent squared minus secant squared over my common denominator of secant squared, but because of your Pythagorean identities, you know right here that if I group these together, tangent squared minus secant squared, okay? Tangent squared, subtract the secant squared to the left, then subtract the 1 to the right. So the difference of tangent squared minus secant squared is -1. And that means that 2 plus -1, or plus a -1, 2 minus 1, is simply 1 over secant squared. Oh, will you look at there? That's cosine squared. And that is also a perfectly valid way to do this. So, you know, when we ask you to show your work, you definitely need to show your work so that we can see how you are progressing and what steps you're using and what identities you are using when you are simplifying this. All right, so we will finish this worksheet and work them together in class. See you then.